Okay, this is number 5 on page 589. In this problem, there's two different scenarios about where we assume the fire is with respect to the two fire stations. So I'm going to show both cases. First of all, we've got a fire that's sited between, that two ranger stations can see, and the two ranger stations are 5,000 meters apart. So if this is 5,000 meters, and I'll just call this station A and station B. If the fire is somewhere between these two stations, and we're going to form an acute triangle from the lines of observation to the fire, then we've got this station is closer than this one, this angle is smaller, this station is farther from the fire. So this one would have the smaller angle, 41 degrees, and then the 52-degree angle goes here as far as the line of sight to the station. So anyway, the question asks, how far is the fire that's closer from the fire? What's the distance of that line of sight? So they're looking for this piece over here, side little a. So I can use the law of sines, but I need to first, I've got an angle and the side opposite it, and I have the side opposite an angle that I don't have labeled yet. So in there, this is going to be the sum of 41 and 52 taken away from 180 degrees, and so that's going to be the 87-degree angle, the other part of the 180 degrees. So now I can say that the sine of the 41-degree angle is to side A as the sine of the 87-degree angle is to 5,000 meters. And cross-multiplying, A times the sine of 87 degrees is equal to 5,000 times the sine of 41 degrees. And then to isolate A, to solve for side A, I'm going to divide out sine of 87 degrees on both sides. So now I have A is equal to this expression, and when I simplify that, I get 3,284 and 8/10 meters, and we're supposed to give this to 3 significant digits, so that's not going to round up, so I would say this is 3,280 meters. Okay, now I'm going to contrast that with case 2. So I'm going to flip the paper over, and for case 2, the fire is not between the two stations. So in this scenario, I still have the stations on this 5,000 meter line, but instead of being at a point up here between the two, I'm going to put it over here and create this obtuse angle here at angle B. And the line of sight I still have to measure as this line of sight right here, because it's the acute angle, it's not an obtuse, it's 52 degrees here, and then this is the 41 degrees. And so in order to find the angle in here, this is the difference between 180 and 52. So this is 128 degrees. And then 41 and 128, when taken away from 180, leaves 11 degrees for the angle up here. So then I, again, can say the sine of the 41-degree angle is to this side I'm trying to find, A, as, and again, they asked for the one that's the line of sight from the closer fire station, which is still going to be this one. So the sine of 41 degrees is to A as the sine of 11 degrees is to 5,000 meters. Again, cross multiplying. And dividing out the sine of 11 degrees on both sides. A is equal to this expression, which is 17,191 and roughly a half meters, and so to 3 significant digits, it's going to round up, so it's going to be 17,200 meters along that path. So it obviously is not drawn to scale, but because this path this would actually be quite a bit longer. It'd be longer than the 5,000, but you get the idea, and that's number 5.